This is a new Newman motor that's set up inside of a bowl with a neodymium magnet with the magnetization through the center. So it's 1 inch in diameter inside of a little coil bowl. And here it is. It's very simple. It has hardly any electronics to it at all. It's a, as I show the diagram, it is a little rotor and a coil underneath. And then the coil, there's a little commutator, which is nothing but a piece of tape on one side. Goes back to the return on the 12-volt supply. And you can hang a diode and a capacitor onto the coil, which shows the back spike energy goes all the way up. Now the equivalent circuit is just 12 volts to a coil, to a switch to ground, and then coming off one side of the coil is your diode. You can capture the energy, the back spike energy. So I'll show you how this charges up. Okay. Probably goes 4,000 or 5,000 RPM. And the charge voltage on the diodes all the way up to 90. And this particular kind of capacitor is a 450 volt and 390 microfarads. So you could probably put several of those in parallel. I wanted a high voltage so it would withstand the back spike energy. The commutator is nothing but a piece of scotch tape on the shaft. Now we're up to 163 volts. Now one other thing is this only uses probably 1.5 or no, actually fractional watt, probably half of a watt. So it's very low power. So I would like to experiment with different capacitors to see how much energy I could actually recapture. The beauty of this is that there's no components to buy. Essentially, you can have a Newman motor. It doesn't need any components other than the coil of wire that you could see, the coil of wire on the bottom. It's just a little solenoid coil with about 300-400 turns of number 22 wire. So I hope to experiment with different geometries to see which one is more efficient. Hope this gets people going on this. It's so easy to make a little motor generator with minimal amount of components. Okay, thanks a lot. 194 volts so far.